Hello everyone. Yesterday we were solving the problem like this longest substring without repeating characters. So our O of n square problem didn't passed all the test cases. Like one test cases we were unable to execute because of the time limit exceeded exception and memory limit exceeded exception. So we'll try and solve this problem using the sliding window pattern algorithm. So I have copied the logic from ChatGPT to like apperaser.io. So as I told you, I have already we will be discussing the problems and the step-by-step logic to solve the problem, and then at the end we'll be solving our uh, uh, algorithm like in the programming language of our choice, like Python, Java. So once we understand the algorithm, the implementation logic becomes simple. So let's try and solve this problem. So before solving, let's understand the problem. So let's a substring is a contiguous sequence of characters. So we'll be given a string, and our goal was to find the longest substring that contains no repeating characters. So one of the examples we took was ABC, ABC, BB. So the answer is ABC and length is 3. So what is the step-by-step logic? Step 1 is use two pointers sliding window. Imagine a window or frame that slides over the string. One pointer starts, marks the beginning of the current substring. The other pointer end explores the character ahead. So I have taken this example and so let me create the pointers. One pointer. So as per the explanation of the step 1, we have to imagine a window or frame that slides over the string, and one pointer starts, marks the beginning of the current substring, other pointer end explores the character ahead. So let it be start and end. So initially they both had an index, starting index. You need a way to remember the characters you have seen and their last in positions. So you need a way to remember the characters and their last in position. Use a map or set of tracking. Map helper if you want to know where the repeating character occurred. So let's create a map. So this map will contain, initially it's empty. So this map will contain the characters we have already seen and their positions. So what is the index of their last seen position? Start and end at position 0. So as we have already done that. And as you move end forward, check if the character who is not seen before, expand the window. So start both and end position as you move end forward. So we'll be moving end forward. So in that case, if the character is not seen before, expand the window. So if the character is not seen before, expand the window. If the character was seen, so where do we find whether it's seen or not? We just created a hash map, so it will contain the last seen positions. So if the character was seen, you find a repeat. So if a repeating character is found, you shrink the window from left. So let's expand the window first, then we'll go to the next one. Start both the start and end position. As you move end forward, check if the character was not seen before. Expand the window. If the character was seen, you found a repeat. So this is our end. So last scene of A was 1 at index 0. So A was not seen. So if the and then we are moving this end forward. Fine. B was not seen. So B is not in this one. So we'll update this one. So B will be at index 1. Again, we'll move forward. Yeah, before that, there is also one more step. So we need to understand both steps first before updating and expanding our window. So if the character is found, you shrink the window from left. So suppose here our character will be found, A is already seen. So we'll have to move this one left pointer. So why we do this? Because this guarantees all characters in the current window are unique. So it's not like we have to move this by one position. So we have to move this one, like there is a mechanism, there is like we have to move from the last scene plus one. So suppose here we will be seen A. So last scene will be of A will be this one. So it will come to here. So I will go through the iteration first. Let me understand the sets. Let us understand the steps. So while moving through the string, we'll have to track the maximum length of all strings with unique characters. So it's calculated as end minus start plus one. So let me bring this both forward and delete this one. So we have to track one more variable. Max length. So let it initialize with 0. So here we have our this one will contain the last same positions and this will contain the max length. So so let's begin the iteration. Excuse me. So we have not seen the A. So we'll update this A and its position at 0. And max length will be, so there is end is equal to 0 and the start is equal to 0. The max length becomes end minus start plus 1. So it will be like 1. 0 minus 0 plus 1 is 1. And our last scene will be at 1. Now we'll move our peak forward. So end becomes 1. We we didn't have B in the last scene, so we'll update our B to at position 1. Fine. Max length becomes end minus start plus 1, means 1 minus 0, 1 minus 0 plus 1 is equal to end minus start 2. So our max length becomes 2. So this is the 1 minus 0 plus 2. End is 1, start is 0 plus 1. So this one becomes 2. Find. And now B index we have updated. C will be at 2. C is also not in the scene. So we'll add the C position. C will be at 2. Max length becomes end becomes 2. So max length becomes end minus 2. End minus start. 2 minus 0 plus 1 is equal to 3. So max length is 3. Now let's move again end forward. So end becomes 3. But A was already there. So when A is there, so we'll have to update our last scene. Yeah, like the start to last scene position of the this character where the end is plus 1. Means the start will be updated to the current character's position plus 1. So A character position was at 0. So our start will be 0 plus 1, 1. The start becomes 1. And max length will be max of max length and end minus start plus 1. So current max length is 3. Current max length is 3. New max length will be 3 minus 1 plus 1. End minus start plus 1. It will be 3 only. So it becomes 3. So max length is actually calculated as max of current max length and the end minus start plus 1. So end is our 3 minus start is 1 plus 1 is 3 minus 1 is 2 plus 1 is 3. So 3 and 3 both are, then it's 3 only. So max length remains 3. Fine. Now let's move to the B. Yeah, before moving A, we didn't update this last position. We had to update our A's position as last seen was A. So before we move our A, so we'll update our A's last position as 3. So B will be at 4. Again, B is in C at position 1. So again, max length will be 4 minus 1 plus 1. Uh, no, before updating, we have to update the B also. So B will be at current position of B, which is 1. So at the end we have this character. So always remember we have to check the ends character. So what is the start will become the ends character plus one. Last seen character plus one. So last seen character is B plus one. So it will be at two. Last in position of B will be four, but the start will become last in of B plus one. So it was one, no. So it will be here. And then again max length is 4 minus 2 plus 1 is 3 only. So it remains 3. Again moves the C. C is in last character. The start becomes last character position of C was 2 plus 1. So this one C will be at 3. Fine. And max length becomes end minus start plus 1. 5 minus 3 plus 1 is 3 only. Uh, Fine. So C will become 5. Sorry, C will become 5. Max length remains 3. So all these are being updated with the last in positions A, B, and C. So B was last in at 4, C is last in at 5, A was last in at 3. Now again move B. B is in last in. So the start will become the B's position plus 1. I may have done some mistake. Sorry. So I moved from B's position to 1. Start B's position. No, it was correct only. So last B position was at 4 plus 1. So it will be at this position 5. So I hope you are getting, I may be updating wrong, but hope you are getting the my concentration and focus is little less. I am giving a lot of stress on my brain. So yeah, fine. Now let's move. So max length is will be like a start end minus start is like 6 minus 5 plus 1 will be 2. So 3 is greater than 2. So max length remains 3. Again move B. So start becomes 5 plus 6 plus so start becomes like this only here. So 8 minus start plus 1 is 1. So max length will again be max length as 3. So this way we'll have to solve this problem. Uh, I hope you are getting what I'm trying to explain. So let's try to solve this problem in code. So we'll have our last scene as a dictionary. So let me write in. So our last scene will be a dictionary. We'll have our end and start both initialized as 0 and max length. So you'll see how easy simple it becomes. Think if you have solved visually. Uh, the max length is 0. So these are the only max length and start at last scene. So in Python, string is an array of characters. So we can iterate through the strings. So for character in string, but we need the indexes also. index comma character in enumerate. So enumerate is a function that returns a tuple of uh, index and a element in the current iteration of the element. In the current iteration of the character array or integer array or list. So here we are iterating over a string. String is an array of characters. Uh, so we'll get a tuple of index and character when we are iterating over a string. So fine. So if character in last string, if character in last string start is equal to last in position of the character, max length is max of current max length and end minus start plus one. So end minus start plus one will give us the current sub string length. So before calculating the end minus start one plus one, we need to update the start because if we have already seen the last in character, then the current substring becomes uh, last means they do not have repeating characters. We'll have to move our start pointers. So when we see a character as repeating, suppose here we came at position A. So as soon as we see there is an A, so we'll have to move our move to start position. So so that BCA will be a non-repeating sequence. So this way we'll have a non-repeating substring. So max length is max of current max length and end minus start plus one. Otherwise, else max length is so max length remains as it is. So we don't need to create an. So for IDX comma character in enumerate of S, if character is in last in start, it becomes the last in of character plus one. Otherwise, max is max length of end minus start plus one and end plus which equal to one. So we don't need the index and character we need. For character in a string, if character is in last string, last in, so start becomes last in of character plus one. But we also have to update our last in, no? Last in of character. I was doing right. I did wrong. So we have to get the index of the last in character. return max length. Let's try this solution. What happened? Oh, there was an indentation. In Python, you have to take care of the equal number of indentation. The wrong answer. Hi. Hi, 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 hi. So I might not have understood correctly. Let me see. No repeat found. Expand window. End plus plus. Fine. If characters in window range, start is last in plus one. Fine. So yeah, I'm doing it correctly. Let me just check what is the index and character. What I'm doing wrong? I'm not getting. Oh my dear. Let's print everything. Going to start print last scene. So 0 A. Start is 0. Start is 0. Now we are getting output as 6. Let's print end of. Start and it is 0, 0, 0, 1, 0, 2, 1, 3. So maximum should be Array, what's the issue with Leetcode? Suppose this answer is correct, solution is correct. Oh, so we are at the current index. We can just give Massimo character is called. Now let's check. Yes. So it's a very simple our solution. So let me submit and check whether it's oh again now it is not even passing. In both cases we are updating the last scene. So I'm debugging. Once it's like resolved, then we'll be solving again. Then I will explaining. So I'm getting output as 3. How? So end start max length is equal to 5. So if character in the last in not in last in, start becomes last in of character is equal to idx. Becomes so we can't update end like this one. Yeah, yeah. Hello. Hello. Am I speaking to Nitish? Yeah, you're not in. You're in range. I'm not getting. Yeah. What? I am Nitesh only. Nitish, this is Hafin. Are you looking for a job change? It's from Java with Python as a C2H position with Infosys. Yeah, fine. Okay, so right now are you serving notice or how it is? I am immediate joining. I'm searching for job. Okay, when you left the organization? I have not worked in Infosys. I have worked like in the last. No, I said this position is for Infosys as a C2H. Yeah, fine. Okay, and your last company was HCL. Yeah. And when you left the company? 16th February 2023. Okay, and your overall and relevant experience? 7 years, 9 months, exact experience. And relevant to Java and Python? 5 years around. Java 5 years. Yeah. And in Python? Same. Okay. And your location? I'm in Dhanbad, Jharkhand at present. Okay. And do you have the PF? I am not getting it. PF do you have? I have PF. Like in for all three companies, I have same UN number and PF account. Yeah, yeah. Okay, okay. And your CTC last and expected? CTC last was 10 and expected is 15. Do you have any offers in hand? Nope, not at present. Okay. And your highest degree and passed out year? Passed out year was 2015 and the highest qualification was BTech. Okay, okay, I will forward it and I will check the screening feedback and get back regardless of. Yeah, fine. So where is in our explanation there is missing one point. You have to check in the current window. So if a repeating character is found, you shrink the window from there, move start ahead of the start both start and end at position 0. So as you move end forward, check if the character is not seen before, expand the window, yeah, end plus 1. If the character was seen, you found a repeat, but yeah, there should be like in the current window. So actually we are missing the point, like this is a sliding window algorithm. So if the character is found and within start, so it should be less than equal to greater than equal to start and less than equal to end. So yeah, this we didn't take into account because this example didn't required us to for last in character. uh, if the and last scene of character is greater than equal to start, it will We now let's me check. Oh, accepted. Even the interim devta is also present with me. Hmm. Yeah, fine. So I hope what you got the crux of the algorithm. The crux of the algorithm was sliding window, and and we were doing that part only wrong. So we are not checking within the current window. So there may be a like some last in, but it's not within the current start and end. So it may be previous position. So then we can continue updating our end position. So this if condition will execute only if the character is in last in and within the window. Last character is getting obviously it will be less than equal to end because we are having the end updated at the from the end means end is at the end only. So like we are updating start and it will be less than equal to end. So yeah, fine. We don't need to give the end condition also. So this way our problem is solved. So this one will be only in O of n time. Yeah, and space wise, since we are storing the last in position, it will be O of n space. So this was our solution. So let me just do some optimization. Your runtime is reduced. So yeah, we need to just have this condition for the sliding window. So our like character scene should be if not in range, we can just keep on updating our end position and updating our last seen character of the index. So it will guarantee our unique characters. So yeah, this way our problem is solved. So we'll try to solve uh, another problem uh, like in our next live session. So yeah, till then, bye. Take care.